This is video on projectile motion. We are going to do problems of type 2. And in type 2, we have grouped the problems which have starting and ending position at different levels. What I mean will be clear in a moment. See, when we did type 1, we did problems of the type where projectile starts from one level and ends at the same level. So it starts from origin and ends on the x-axis again. But here we are going to do problems when projectile starts from origin or starts at a level and stops either above that level or below this level. Only thing is, in these problems, time will not be involved, in the sense you will not be asked about how long projectile has taken to do so. That will come in the third type, which we are going to do in another video. So, looking at type 2, let's take a numerical. It says a stone is thrown from an elevation of 2 meters such that it clears a wall 8 meters high situated at a horizontal distance of 35 meters. If the angle of projection is 60 degrees with respect to the horizontal, what should be the minimum velocity of projection? That is what is asked. It's always better, in fact it is necessary, to reduce the problem to a pictorial form. So this is what it reads. A projection is from 2 meter elevation, and what you are told is it clears a wall 8 meter high. Now mind you, no one has said that 8 meter is the maximum height of projectile. It is just a point on the projectile path. Best way to do these problems is we use the path equation, because the path equation doesn't have the time t, and it suits us fine for the purpose of this problem. Now we substitute the numbers like this. What I want to point out to you that value of y is not taken as 8, but it is taken as 8 minus 2, 6. Reason, if you are going to use this ready-made equation, then we have to follow some restrictions which were posed when it was derived, and that restriction is the point of projection has to be origin. So we have kept origin at the point of projection, which is 2 meters above the ground, and therefore from there, if we measure y, it will be 8 minus 2, 6. Then x is 35 and 60 degrees angle of projection, so that is alpha. And then you see in this equation there is only one unknown u, which is not difficult to find, and that is what was required. Okay, next problem. It says the shell is fired at velocity of 50 meters per second and it hits a target 197.52 meters away from the gun and 10 meters above the level of it. What we need is find the angle at which the shell is fired. So in the previous problem, angle was given, projecting velocity was asked. Here, projecting velocity is given and angle is asked. So this is a pictorial view, and we use the path equation like before. Only thing is we need to do little bit of trigonometry here. 1 upon cos square alpha is equal to sec square alpha you put, and then you also use this identity, sec square alpha is equal to 1 plus tan square alpha. By doing this, we will be able to get an equation which is quadratic in tan. And we know values of y and x, we put them there. Y is 10 and x is 197.52. Only unknown which remains is alpha, which is in the form of tan alpha. Tan alpha is quadratic in this equation, no difficulty solving it, and you get alpha, two values, 29.2 and 63.66. That is expected, because after all it was solution to a quadratic equation. And what it practically means is there are two angles of projection which will satisfy this xy coordinate of 197.52 and 10. So these are the angles. These are the angles, possible angles of projection. Next problem says a ball thrown by a player with an initial velocity of 15 meter per second from a point 1.5 meter above the ground. If a ceiling is 6 meter high, determine the highest point on the wall at which the ball strikes the wall 18 meter away. Now, pictorial view of the problem is this. Now see what they mean by ceiling is 6 meter high is they are telling us that the maximum height that projectile can go to can't be more than 6 meter from the ground level. See, it is in fact an example of a squash game where 1.5 speaks for the racket height from which the ball is thrown, and you see the ceiling height is restricting, and then there is a wall in front. Now no time is asked, so I can go back to path equation, but there are more unknowns. See, there are more unknowns. Y is unknown and alpha is unknown. Therefore, additional equation of maximum height I have to use. So if I use h equal to u square sine square alpha by 2g, and here I substitute h, but one must note that h I have not put 6, but I have put 4.5, which comes if I subtract 1.5 from 6. And why do I do that? Because even this equation, when it was derived, it was assumed that the point of projection is origin. So here the origin is 1.5 meter above ground, and from there we measure y, or the maximum height of the projectile. And therefore h is 4.5, u is 15, and alpha is unknown. That's fine. But and it is possible to work out alpha from here, which we did, and then we put it in the path equation, because now unknown is y, but x is known and alpha is known, and that's why you can work out y, which comes to 2.54. But mind you, if see what is asked is highest point on the wall. So if you want to give that to this 2.54, you need to add 1.5, because see, our origin and x-axis is 1.5 meter above the ground, because we have used ready-made formulas, and therefore the height where the wall hits the ball, the height measured from the ground is 2.54, which you worked out, plus 1.5 from where the projectile started. So it comes to 4.04. That's the answer. And now next problem goes like this. An aeroplane flying in horizontal direction with a velocity of 540 km per hour at a height of 2000 meters. When it is vertically above the point A on the ground, a body is dropped from it. The body strikes the ground at B. Calculate the distance AB and ignore air resistance. Okay. Pictorically, it looks like this. 2000 height is given, and we need to find distance x. You see, now you can say starting point is A and ending point is B. Now 550 km per hour we are converting into meter per second. It's required because G, what we are going to use is 9.81 meter per second square. So everything has to be in Newton. Everything has to be in Newton and meter. Now equation of the path. Equation of the path is y is equal to x tan alpha minus half gx square upon u square cos square alpha. We can apply this equation, provided we remember that point of projection is the origin, which is 2000 meter above ground. Therefore, while substituting, we put y is equal to minus 2000. Now alpha we'll put as 0. Reason, because the aeroplane is flying in horizontal direction, whatever drops from there also has to fly in horizontal direction. So angle with horizontal is 0, and then only unknown is x, and that we can work out as 3028.9 meters. Thank you.